We have seen in a previous lesson how we can add two vectors to create one equivalent vector. What we're going to do here is basically the opposite of that operation. What we're going to do is take one single vector and rewrite it in terms of two different vectors. Instead of having one vector, we're going to have two vectors added together. But these aren't going to be just any two vectors. What they're going to be is one of them, AX, is going to be purely horizontal, and the other one, AY, is going to be purely vertical. These AX and AY are the vector components of our vector A. And what this is doing is addressing the issue that we saw with the tip-to-tail method. When you have a bunch of vectors that are all in different directions, we had to use the tip-to-tail method to add them together to account for their differences in direction. But if we decompose every vector into a horizontal vector and a vertical vector, then all of our horizontal vectors will be aligned with one another, and all of our vertical vectors will be aligned with one another. And when we combine them, it's much simpler to add or subtract or do other mathematical operations with a bunch of vectors that are all pointing in the same direction, whether that be horizontal or vertical. We're going to take that a step farther and introduce what are called unit vectors. A unit vector is pure direction. It is a vector that has a magnitude of 1 in a defined direction or orientation. It's a unitless quantity, so all it carries is that direction without changing the amount or without changing the units of the rest of the quantity. When you have a unit vector, you use a hat, looks like that, to show that that's specifically a unit vector and not a ordinary vector. So in general, a vector A has a magnitude A without the overhead arrow and a direction A hat that points in the direction of A with a magnitude of 1. Because we're trying to get vectors that point in the x and y directions, we have special unit vectors that you're going to need to memorize. The I hat vector always points in the positive x direction, always points to the right. The j hat vector, unit vector, always points in the positive y direction, it always points up. Think that j hat has a tail the way that a y has a tail, and I hat is in our x direction. And so we're going to use these two unit vectors to define the directions here, and it's going to simplify the way that we express those vectors and do mathematical operations with those vectors. When we have a vector, we want to reduce the vector components, which are the vector in the x and y directions, into the components of the vector using unit vectors. The components are scalar quantities, and the unit vectors are in the directions, the x and y directions. So let's imagine we have an arbitrary vector here, and for an example, we've let this vector be 7.3 units at an angle of 344 degrees, so that's a fourth quadrant angle. This is our standard angle, showing this vector in polar form or standard form. To find the components of the vector, we're going to draw a vertical line through the tip and a horizontal line through the tail, and that creates a right triangle. That should always create a right triangle because your two axes should always be perpendicular to one another, so you're creating a right triangle there. Your AX and AY are the components. AX is the length of the horizontal side, horizontal portion. AY is the length of the vertical side. But it's more than just the length because the I hat and the j hat always point in the positive direction, but our components here could be either left or right or up or down. So we do have to include the direction, and we tell the direction with a plus or minus. So in this case, we're going 7 units to the right, so that's a plus 7. We're going 2 units down, so that's a minus 2. So plus 7 is our x component, that's how much this vector goes horizontally. Minus 2 is our y component, that tells us how much we go vertically. If we want to write this vector in unit vector notation, it would be 7 I hat minus 2 j hat. This is telling us we're going horizontally, 7 to the right. This is we're going vertically, 2 downward is our interpretation of that. This is unit vector notation. This is standard notation or polar notation, but two different ways of describing the same vector, either in terms of its magnitude and its angle or in terms of its components. If we have a standard vector, we can find the x and y components directly mathematically using that standard angle. When we have a right triangle, the assumption is that the angle inside the right triangle has to be between 0 and 90, but our standard angle could be anywhere between 0 and 360 degrees. And note that your sine and cosine are periodic functions. They are defined for angles going to infinity. So we can evaluate this angle phi at 344 degrees or at any second or third or fourth quadrant angle. And what you'll see if you plug that into your calculator, you'll see that the positive x component and the negative y component are built into the definition of sine and cosine for a fourth quadrant angle in this situation. So if you use the standard angle, sine and cosine will give you the plus or minus directly. Another method that you can use is whenever you draw the vertical line through the tip, the horizontal line through the tail, and create your right triangle, there you have a right triangle immediately. You can find the angle inside that right triangle. You probably have experience resolving triangles in trigonometry, so you can use the standard angle to find the reference angle. That's the angle inside the right triangle. And then using that reference angle, you can find the x component is adjacent, the y component is opposite, so you can use sine and cosine. But in this situation, whenever you are using a right triangle, recall that trigonometry is sort of based on construction, and so it assumes that you have a sort of physical right triangle that you can measure. In fact, this right triangle is a representation of some physical quantity, a velocity or a force or some other sort of abstract quantity that could have positive or negative values depending on if you're going right or left or up or down. And so in this case, if you use the reference angle, you have to include your own plus or minus to indicate which direction each one of the components is going in. If you are given the components of the vector, if you're given the vector in unit vector notation, you can turn those components into a magnitude and an angle as well. We said that the components are always going to be perpendicular to each other because each component should be parallel to one of the axes, and the axes should always be perpendicular. And so you're always creating a right triangle where the magnitude of the vector is the hypotenuse of that right triangle. And so if you need to find the magnitude of the vector, we're using Pythagorean theorem here to find the magnitude of the vector based on its vector components. The easiest way to find the standard angle is to focus on the reference angle first. The reference angle is inside that right triangle. Assuming we're given the components here, take the absolute value of the components. Don't worry about where this triangle is. Just treat it as a normal physical triangle with positive side lengths. Use inverse tangent, opposite over adjacent, to find the reference angle, this angle inside the right triangle, and then use trigonometry to find the standard angle. So in this case here, this is a straight line. We know this is 180 degrees, and so our standard angle is going to be 180 degrees minus the reference angle that you would have found inside that right triangle. So with a little bit of figuring, a little bit of trigonometry, you can find your standard angle based on whatever triangle we have here. Same idea here. Here, if you knew the sides, you could find the angle here would be about 16 degrees, and then 360 degrees minus 16 degrees would give us that 344 degrees. The reference angle is inside the right triangle, so that reference angle should always be between 0 and 90 degrees. Your standard angle will be somewhere between 0 and 360 degrees.